Welcome to another episode of Matrix Math. We're going to talk about upper and lower triangular matrices and some other properties. So first, what is an upper or lower triangular matrix? Let's just go ahead and reveal that real quick here. Say we have a matrix, we'll call it A, and if it is lower triangular, we'll say lower. I'll just say triag, save some space here. Then that means, okay, well, we look at this center point here, and if this and everything below it is a number and everything above it is a 0, then it's lower triangular. Now that might not make a whole lot of sense. Let's say this is, we'll just keep it simple and make it a 3 by 3. So if we got a 1, 4, 6, 9, a 2 over here, and maybe an 8 over here, and then we have zeros up here. This is lower triangular because, well, I guess it gets its name from this triangle at the lower portion. So there's a lower triangular matrix, and if we want to do an upper one, well, you can guess that it's going to be the upper portion. We have matrix B, I'm drawing black, and it equals, and let's make an upper triag here. Upper triangular. Pretend that looks better. All right. Then it's we'll go off the center, and if the upper portion is filled with numbers and the rest is 0, or it doesn't even necessarily have to be numbers, it just has to be non-zero elements. So I don't know, 1, 4, 6, negative 7, 2, 9, and then 0, 0, 0. This would be upper triangular. Now, one of the interesting properties of these, there's a couple I'm going to talk about here, really just two different properties, is if you multiply two lower triangular matrices together, you end up with the result of another lower triangular matrix. And you can test that out if you want. So this A here, if we were doing A times A, we'd end up with another lower triangular matrix. Lower triangular matrix, I'll call it LTM. And that goes the same for A to any power. So A to the 4th power, so A times A times A times A is still going to be a lower triangular matrix. Now, another interesting thing about it is if you transpose one of these, it turns into an upper. So if we do A transposed, it's now going to be a upper, I'm not going to spell it all out, upper triangular matrix. So it would look more, it would go to that form with the transpose. And if you transpose it again, it goes back to A. So those are some of the properties, and you can kind of scale those all over the place. Like you can do, well, I don't know how much I really want to get into it. But that's the basics of it, really. Is you multiply them together, you stick with the same triangular. If you transpose them, it turns into the other type, and that's really all there is to them. And by book definition, you see stuff like, hold on, okay, by book, how many people is that going to troll? By book definition, you see things like, we'll say A, I, J, where I is the row, J is the column. You see things like when I is less than J. I might as well just type this out. Like when I is less than J, or, okay, sorry. You'll say, okay, A to the ij, pretend those are subset, equals 0 when I is less than J, which basically means the field is 0 when I is less than j. And that would be a lower triangular. So I being the row, j being the column. So if we're in column 2, row 1, then I is less than j is going to equal 0. So that's typically how it's defined in a book. I prefer to just look at it in a more realistic way of, well, this way. But whatever works for you. Academically, you'll see this type of stuff. And of course, there's all sorts of other mathematical ways of representing it. Okay, I think that's going to do it for this upper and lower triangular. I think I've beat it into the ground at this point. Hope you enjoyed. Thanks for watching my video on matrix math, and look forward to the next one. You can show some support by leaving a like and watch the rest of the series if you would like to learn more about matrices and further your development with understanding this type of stuff. Alright, peace out, guys.